Hello everyone, I'm Cauchy and today in this lecture we will be studying about the Cauchy's integral formula. And before that, studying this Cauchy's integral formula, first we will look what we have studied. We have studied the complex analysis, mainly these topics: analytic functions. We have gone through the CR equations. We have gone through the power series, mainly Taylor series and Lorentz series, and we have also covered Cauchy's residue theorem. Okay, now the contour integration is left, and today in this lecture we will be covering the Cauchy's integral formula. Okay, and one more lecture will be on the contour integration, and one more lecture will be on miscellaneous, the topic or the question which I will be covering of all the topics that I have not included till now. I will be making a complete summary of the complex analysis in one video. Okay, so let's start from the today's class, Cauchy's integral formula. In you can say that in UPSC mains question paper in 2013, a question was from this Cauchy's integral formula. It means examination in 2013, and the question was like that: we are required to calculate the integration. This is a symbol of integration. Okay, integration. So let me tell you one thing. Please pay your attention towards my speaking. Whatever I am speaking, that is very much of importance. Okay, my writing is not so good on this screen, so please focus on what I'm saying. Okay, so now let's proceed further. So this was a question: e raised to the power 3z divided by z plus 1 raised to the power 4 into dz, where this circle C, or you can say this curve C, denotes the mode z equals to 2. This implies that the circle with a radius of 2 unit. Okay, so let's plot the circle with a different color so that it will be visible for you. So I'm plotting this. Okay, it's very bad circle, isn't it? Again, what happened? Okay, just for understanding purpose. Okay, this is 2 and this is minus 2. Okay, and now this pole plus 1, this represents that the pole is present at minus 1. Okay, this is the location of the pole. This is pole location. This is pole. Okay, pole is located at minus 1, and where is minus 1? Minus will be somewhere at here, here, minus 1. Okay, since the pole is lying within the circle, then the Cauchy's integral formula exists. And what is Cauchy's integral formula is? I am writing the formula and I am changing the color for the sake of visibility and for the sake of understanding. The formula will be the integration of a function f of z at any pole. Suppose this is the pole is present at z equals to a, then it will be z minus a with respect to dz, and I am assuming that the pole is lying within the curve C or within the circle C. Then this will be equals to 2 pi I multiplied by f of a, the value of the function at that pole. Okay, this will be the formula. And if this pole is not lying within the circle, then the answer will be equal to 0, zero, 0, complete 0. Suppose if here the statement may be like this: z plus 3 raised to the power 4, it may be like that. Then minus 3 will be lying somewhere at here, minus 3 will be lying here, then it becomes complete answer will be 0. Okay, now let's move further. I'm removing it, since you know that now the pole is lying within the circle. Now the Cauchy's integral formula is applicable, and when the formula is applicable, what we are required to do? We are required to calculate it. So I have not told you that if the number of poles are single or multiple. Here how many poles? There are 4 poles. Okay, 4 poles are present. If multiple poles are present, then what will be the formula? The formula will be, I am writing it again, the formula will be the same, 2 pi I, but with some new addition. What will the addition? Just do the differentiation one time less than the number of poles present. How many poles are present? 4. Then how many time differentiate? We will differentiate it 3 times. F triple dash z divided by the number of time you differentiate. So put the factorial of that number, 3z. Suppose if here n poles are present, the formula will be 2 pi I. Just put here n. Okay, n, not n minus 1, because we are required to do the derivative one time less. Minus 1, one time less, we are required to do the differentiation. Okay, one time less. Now, and we are also required to divide this function by one number less than the number of derivative. Okay, so this formula is very clear. Now we are proceeding further. Now, since you know that there are four poles are present, then how we will proceed? Here f of z is what? F of z is e raised to the power 3z. Okay, e raised to the power 3z. And now we will be calculating its derivative. The first derivative of this function, this will become 3 into e raised to the power 3z, and second derivative will be equals to, this 3 comes out at 3 into 3, this will become 9, and this will become 3z. And now it's triple dash, that is third derivative. In the third derivative of this function, this will become 3 9 3 27. This will become 27 e raised to the power 3z. Okay, now we have to calculate the value of f triple dash at a, and a is at -1. So just replace the value of z by -1, you will get your answer. This will be the 27 e raised to the power minus of 3. Okay, this is e raised to the power -3. This is the value of f triple dash -1. Now, according to our formula, what will be the question? What will be the answer? Answer will be, this will become 2 pi I multiply by, just do the multiplication, simple multiplication, f triple dash, that is 27 e raised to the power minus of 3 divided by, complete this. Sorry, this is not correct. The line is not okay. This is divided by 3 factorial. Okay, and what is 3 factorial? It is 6. So it become, so I am writing it 3 factorial into 3 into 2 into 1, and I am cancelling this 2 by this 2, and this 3 1 ja 3, and this becomes 9. Okay, so this will become, the answer will be 9 pi I into e raised to the power -3. This is the answer of this question. Okay, and this question comes for the 15 marks in the UPSC mains 2013. Okay, this comes for the 15 marks. If you know the theory behind it, then it is a very easy question. Then if you don't, then it is not. Okay, so this much is for this Cauchy's Riemann theorem, Cauchy's integral formula, and I have told about the formula to you. Now we will be studying another case. Okay, I will be doing the multiple cases. Till now I have just gone through the only one case or two case. Now in this Cauchy's integral formula, I will be dealing with multiple formula. Not multiple formulas, formula will be the same, but multiple types of question will be there. Okay, which type of question I am saying? Just suppose, integrate this function e raised to the power z divided by z plus 1 and z minus 2, where this circle, this curve C is given, and this is dz. If this dz, this C, this curve C which is given, this can be mod z, that is equals to 2.5, say 2.5. okay, since it is 2.5 unit radius circle, so just plot the circle, and the circle will be like this. Okay, and this is the 2.5, so this will become 2.5, and both these points, this -1 and +2, both these points will lie this within the circle. When both the poles are lying within the circle, then the Cauchy's integral formula is applicable. When the formula is applicable, then how to apply that formula? Okay, now I'm eliminating this. How to just how you are required to how you will proceed? You will be proceeding like that. Just put z plus 1 in this side, and do not assume that z minus 2 is in the denominator part. Make the function f of z, just do some very you can say that what you can say,